Flutter Riverpod is very important state management and dependency injection framework in 2026 because in many of the Flutter application recently this state management system is being adopted because it gives many of the lots of advantages. There are some other state management systems are also there, but Riverpod is now come up with lots of advantages, and that is why in 2026 in Flutter application Riverpod is being adopted widely. So this is very important. So we will be understanding what problem it's resolve and how it helps to achieve the state management in Flutter application. So we'll be understanding that part, and we'll have a coding example with how Riverpod works in Flutter app as well. That will be also understanding. If you are new to this channel, please subscribe for this type of videos. So without further delay, let's get started. This document to going through what is Riverpod, and we will be understanding one by one. So Riverpod is basically it's a state management and dependency injection framework for Flutter, as I have introduced you. So now we'll be understanding what problem it resolves. So if you see here, so basically these are the problems which the other state management systems has. So this is first one is the build context dependency, runtime errors, difficult testing, tight UI logic coupling. So these are basic problems what Riverpod is going to resolve. Basically in Flutter application this build context is required in the widgets. So these are the other state management systems which basically has this type of issues. So what Riverpod fixes, how Riverpod fixes all these things. So basically it doesn't depend upon the build context. Then next one is compile time safety, because it provides also compile time safety. Like when we are using Riverpod, in the compile time itself we are able to get to know whether the state would works properly or not. So that part we are able to understand just in the compile time. So that is a very good advantage of Riverpod. The next one is clear separation of concerns. Basically UI and business logic always need to be separate for a good architecture application. So Riverpod also helps to achieve that. Next is excellent async handling. Async handling means when we are getting data from any API and we have to get it, and then at the time, so that is what asynchronously we need to get the data without blocking our UI thread, so that that thing can be handled through the Riverpod. So these 4 points are very very good points which is resolved by the Riverpod. So what is the then what we'll be understanding little bit brief on this. So first one is the build context is not required. That is we will be understanding a little bit more. So basically we can access state inside widgets, inside services, inside repository, inside background logic, so without the need of build context. So that is a very good thing. So little bit brief on the first point. The next one is so by using this ref.read, ref is basically it's a refers to it's a reference, okay, reference to the like Riverpod provider, right? So Riverpod.read counter provider. So this means, for example, reference.a it basically provides the state of the data, right? So that is what. So this is a syntax of Riverpod. Like ref.read means it is just get one time it will watch that state value using the help of Riverpod. It's a syntax, okay. Ref.read counter provider. Counter provider is nothing but a provider, and read means it's a syntax of Riverpod reference. So it can get the value of the state at once. So this is a concept. So there is no use of build context, right? That is what it trying to understand. This is a huge for clean architecture, right? Yeah. So next one is compile time safety. Okay, so compile time safety means in the compile time itself we are able to get to know whether the states are working properly for the the state of the data is working properly or not. That we are able to get to know in the compile time. If you misuse a provider, Flutter tells you before runtime. Okay, like if anything if the like for Riverpod, when we are implementing the provider, if anything wrong, so in the compile time itself we are able to get to know. That is the point here. So there is a like a chance we will not miss the state management using the help of Riverpod. So it will lead it then helps in fewer crashes and faster debugging, right? Yeah. The next point is powerful async handling. This is a game changer kind of thing. So Riverpod handles loading, error and data. There are three things it is handling. I mean, let's say we are getting the data from through a API, and when the data is not yet received from the API, and that is why we have to show some loading, right? So that part is also can be handled easily using the help of Riverpod. Then there is a possible chance we will be getting some error, right? So that can be handled. Third one is the data, the actual data we are expecting from the API. When that will come, we'll able to handle that as well. So these three state can be handled for Riverpod. So this is a like a kind of written automatically by a async value, and this is a kind of no more manual try catch loading flags required. So that is what all about powerful async handling can be achieved easily using the help of Riverpod. Then built-in dependency injection. So this is built-in dependency injection means provider can depend on other providers. So here this is a syntax of Riverpod. Provider means it's a type of Riverpod. There are different type of Riverpods providers are there. Riverpod types are there. So provider is one type, right? So this is provider of type API service. It is taking the reference, then return API service, a reference.read, HTTP client provider. So HTTP client provider is another provider. It reads its value and returning to this API service. I mean, this is a even here. Basically it's a built-in, it shows as a built-in dependency injection because it provides also dependency injection capabilities to other providers as well. Then next one is easy testing. So we can do easy testing by like we can override providers in test as well. That is provider scope. We can override this API provider dot means it's example like how to test for the provider as well. We can do some mock API and we can test that. That is what we can also do that. The next is the type of Riverpod providers. That is very important to understand. So first one is the provider. Provider is a type of Riverpod, right? So when this can be used, basically it's for read-only values or services used for API clients, repositories and utilities. Here is a small example, like this is a provider type of like provider, it's a like API service provider, and it is taking the reference. So this is syntax we have to understand for Riverpod. This is just basic syntax, and it is returning that API service. Okay, so we can create a provider type Riverpod, like it's a provider type Riverpod, right? Next one is StateProvider. StateProvider for simple, it is basically used for simple mutable state, used for counters, toggles, simple flags. So here is the syntax, like final, this is a counter provider, is a variable of type StateProvider. It is of type integer, it is taking reference which is initiated to 0. So this is a syntax of StateProvider. Okay, here is a note like avoid for complex business logic. This is no need to use. Okay, the next one is state notifier provider. For it is used for basically complex state plus logic. Most used in real apps, best for MVVM or clean architecture. This is a syntax for that. Final, like final auth provider. It's a name of the object we can say. Then this is state notifier provider. This is a type. Then it is taking like auth controller and auth state. This is a syntax, okay, and a reference to auth controller. So this is a kind of syntax we have to use how to create this state notifier provider. Next one is FutureProvider. So FutureProvider is basically used for API calls or one-time async work. This is the syntax for the FutureProvider, like user provider, final user provider equals FutureProvider type. Then it is taking user. I mean user is type of FutureProvider, reference async, return API.get user, like whatever API we are using, this is the method to get that data and we are returning here. Okay, so this is the syntax of, if you see my cursor, this is the syntax of FutureProvider. What it auto handles, loading, error, and data. That also we can handle easily. Then next is stream provider for real-time data. Real-time data means like location updates, then WebSockets and Firebase. So these are kind of some of the real-time data we can use the stream provider. So stream provider syntax, how we can create, like this is a list of messages of type stream provider, and reference, basically this is syntax, and we can return chat service dot stream messages. So it's a just for example you understand, this is a object of chat service and we are calling and getting some stream messages, so we are returning here. Okay, this is object is being created, then we will be used it in our widgets. So this is how the stream provider can be created. Next one is notifier or async notifier. This is modern and recommended. I mean, this is newly introduced. So in Riverpod 2.x best practices, so cleaner, less boilerplate. This is how we can create a notifier, like class counter notifier extends notifier, and it's of type int. We can override build method of type int initialized to 0, and we can like this is an increment method state plus plus, so we can do like this. Okay, so this is how it's example of notifier or async notifier type Riverpod. Okay, when should you use Riverpod? Use Riverpod when app grows beyond 5 to 6 screens. Basically it ideal when your application size is having 5 to 6 or more screens. That is, in that case we can use that Riverpod. You need clean separations. When we need clean separation, right, when we have some in the application has some multiple features, and we need proper separation of concern, that in that case we have to use Riverpod. Then async APIs are heavy, like there are multiple async calls there, we are calling multiple APIs. In that case it is also recommended to use. Then testing matters. I mean, when testing is very crucial, we are focusing on testing part as well. In that case it is also very useful. Team collaboration is definitely when we have multiple team members to work, then in that moment also it is also helpful as well. Like to collaborate with other team members, we can using the help of Riverpod, it would be easy to manage that part as well. The next is when we are following MBBM or clean architecture. In that case implementing Riverpod helps to helps to manage that clean architecture as well. To data flow, it is very good to manage using the help of, I mean, Riverpod plus MBBM or clean architecture is best combination for use in the code. Okay, so also we need to know when to avoid Riverpod. That is also very important. When we have a very small screen, like 1 or 2 screen, or temporary, we have to we have UI only one state. In that case it is not required. When your app is scaling, in that time we have to adopt Riverpod. If it is just for a very simple one screen and there is nothing to do much with the application, very simple, in that case no need to go with Riverpod. So now we will be seeing there are some popular we have block state management system as well, and Riverpod and setState. So we need to understand the difference of these three, because block and Riverpod is usually popular when to use in a mid-size application, like mid-size to bigger applications. So in both the cases, block and Riverpod is used by many companies, and many other some applications using block, some applications using Riverpod, but here Riverpod has some more advantages as compared to block. So we'll be understanding that part here. So first one is boilerplate, like whether it come up with some boilerplate code. For setState, it is very low, because this is a setState is very basic for the stateful widget. The next one is block. For block, definitely there will be boilerplate. I mean, the complexity is more while we are choosing the block. Riverpod, it is not that boilerplate, because it is because of it is doesn't depend upon the build context. That is why it is moderate. Okay, so it doesn't have much complex as compared to block. Then second one is scalability. For scalability, setState doesn't help at all. The next is block, it is fine, we can go with. Then Riverpod, it is also fine. Okay, next one is async handling. setState, it doesn't help at all. And for block, it is works for manual. Okay, and in Riverpod, it is working very nice. That is the advantage of Riverpod. Then learning curve. Learning curve for setState is very easy, because it usually basically used for simple task, not for much complex. Next one is block. Block, basically learning curve is hard because the implementation part is a little bit complex. Then for Riverpod it is moderate. I mean, that is why, because as the implementation is not much hard, that is why learning curve is less. Okay. The next one is recommended in 2026. What is actually recommended? So as per my understanding, as per the current trend of state management in Flutter, so in 2026 it is highly recommended, and every Flutter developer should adopt it in the application. So it is a very important in terms of state management, right? Next one is, we'll be understanding a clean architecture with Riverpod, how it works. So this is architectural diagram. If you see my cursor here, first one is UI layer. UI layer is having basically widgets or screens, and for the Riverpod it will basically need consumer widget instead of stateful widget. It actually need consumer widget to work with Riverpod. So just we need to use consumer widget for the Riverpod. When Riverpod is being used for this UI layer, consumer widget is basically used for instead of widgets. So that is what basically for the UI layer. Next one is it is lesson 2, state management. State management means what? Riverpod providers or like Notifier or async. Basically it's a Riverpod providers implementation. The first layer is a UI layer where the user is interacting. That is what the consumer widgets or screens is visible, right? Second one is the state management part. State management is basically nothing but the Riverpod providers. It is example like Notifier or async. These are kind of providers. Okay. Then next, this providers will call to the domain layer. So basically some use cases are business layer. It means then this provider will talk to this domain layer. Domain layer is having the business logic. Okay, it has some use cases and business logic. It will talk to that. Then finally this domain layer will ask to the data layer. So data layer is nothing but the repository, API or DB or cache. So these are finally, so for the clean architecture using along with the Riverpod, this is the architecture to be followed. Okay, the first one is the UI layer, which is nothing but the widgets. For the Riverpod implementation, we have to go with the consumer widget. That is one. Then this UI layer will talk to this state management. State management systems means here the Riverpod is the state management system, and it will, let's example, Notifier or async. This is example of Riverpod providers. Then this will talk to the domain layer. Domain layer basically that business logic part, which is having some use cases. Then this domain layer will talk to the data layer. Data layer is having this repositories, APIs, database or cache. So that is how the architecture need to be created for along with the Riverpod for the Flutter application. So basically this is a document I will be sharing in the video attachment, and you can download it and go through it just for what is Riverpod and what problems it resolve, plus what are the type of Riverpod we have understand with some of the basic examples, and how it compared to block and state management system, how it differentiate from them, and it is also very much recommended state management system in Flutter development and in 2026. So now we'll be going to Android Studio and we'll be seeing like a coding demonstration how basically Riverpod works with only one type of provider we'll be using there, and we'll be seeing like how it works. Okay, so let's jump to Android Studio and we'll explain that as well. Okay, now we are in the Android Studio, so let's go through this Riverpod demo example, and like we can understand how Riverpod works, and there are some steps we need to follow to implement Riverpod in the Flutter application. So here you can see it's a like a Flutter demo. I have just name it as a Flutter demo application, and this is the popspec.yml file where we need to add the dependency. So for this Riverpod to use in the Flutter application, so this is, you can see this Flutter underscore Riverpod word like a dependency has been added. So this is inside the dependency block. Okay, So this is the library version name of Flutter Riverpod. So after adding this, we have to sync it using pub.get. So it will be now added to our project. This is the step 1. Next step is there are two Dart files. So this is the main.dart file, which is the starting point of the application. So in the main method, there is a this is a my app stateless widget. So in this stateless widget, basically we are wrapping it up with this provider scope. So provider scope need to be wrapped with the the first widget. That is important to so this is basically syntax. We have to always wrap it up with provider scope to use the Riverpod. Okay, so here the comment is also written like this widget is what store the state of all your providers. So wrap your entire app with the provider scope. So this is the syntax we need to understand to use Riverpod in the Flutter application. Okay, so now this is a stateless widget. Inside that we have a my home page. So my home page is another widget, but this is not a stateful widget. This is a consumer widget. So this is important thing to understand. So instead of a stateful widget, we have to use the consumer widget. So that is what it will consume our state of the providers. That is why the name consumer widget is named here. So what it is doing now? So it's basically it's a UI layer, like as I have told you, basically this consumer widget is part of UI layer. Okay, so inside this this is the build method, and what it takes two argument. One is build context, another is widget reference, right? This is widget reference. This particular thing is actually important here to understand. If you see the cursor, this will handle the providers, right? So here this is the first line. This is watch, like ref.watch counter provider. So this is this particular reference, or we can say this is the object of the provider actually that will go. But now you understand that this implementation part first. So ref.watch, what it does, this makes the widget rebuilt automatically whenever the counters value change. I mean, it will keep on watching means it will keep on observe the provider. So what is the job of the provider? Provider will give the state of, I mean, state means it will provide you the value when it will get changed. When it will get changed, this watch method will keep on watching. If this counter provider will have a change, it will give that latest value in this counter value, right? That is what it is. Next is this is a for the UI. This is a scaffold. Inside the scaffold, this is app bar and title. So this is for it's a simple UI. This is the center, this is another widget. Inside that, this column widget where some alignment is there, and we are showing that text, that is the counter value, right? This is what the updated value will be showing here. So it's a very simple demonstration. I'll be run this app and I will show you the UI how it works. But you understand, try to understand how this Riverpod works here. Basically, if you see what is the point, need to first understand. Your app should always wrap up with provider scope. That is step number 1. That is basically step number 1 in the widget part. Okay. The next one is we have to use the consumer widget instead of stateful widget. And if you see, the build method has two arguments. One is build context, another is widget reference, right? And this watch method will keep on watching that provider. Okay, it will check if any data is updating in the counter provider. We'll go to the counter provider, and next step is this is the UI, just to show the current updated value, what is in the counter value, right? Then this is a UI just to we are just it's a circular floating action button. Just need to click on that. It will call the method in the provider just to increase the value of that particular state or that integer value. Then for that thing, what we are doing, this is a reference.read method we are calling of that provider. We use the read method here because we are not listening or for changes, just calling a function basically. Okay, so we are just use this method just to get the notifier and call its increment method. So we are just calling a method of the provider. So just to increment is a method, it's a user defined method, and we are just let's go to that provider part. So there are two things. One is this we are calling this watch method just to observe the value, but actually we are doing the increment here in this part. So that is what on press reference dot read, then in the counter provider dot notifier, this is a syntax, and this increment method we are calling. So this is the increment method. So this is like as I have told you, there are multiple type of Riverpod providers are there. So here we are using this notifier provider. Okay, for the notifier provider we need a notifier as well. So notifier of type integer, this is the counter notifier. We are extending notifier of type integer, and here this is the build method which initializes this with the 0 value. This is the initializing of this, because we are using the integer type, so initial value is the 0, we are whatever value you can give it is. Okay, then increment is a user defined method, and state is a user defined. It's a system like this integer value is already defined in the notifier. That is why we are able to use this state without write by without create by ourselves. So state is already available in this notifier class. So notifier, we are just what we are doing, state equal to state plus 1, we are just incrementing the value, right? And after that we are returning here in the last part. What we are doing, this counter provider, counter provider is the reference of this notifier provider we will be using in our widget class, and this is taking counter notifier. Counter notifier is this is the notifier class, and integer, this is the syntax of notifier provider. Okay, so this is very simple example of how provider works. So what is the job of provider is, it will provide the state of the latest value. State provides different type of providers. In different use cases we can use different type of providers. So this is a very basic use, and then if I click here, it will just increase the value by this calling this into here in this by using the help of this watch method. Now let me run this app. Okay, the application is now started executing, started running now. Yeah, now it is installing in the emulator. So you can see it's a Riverpod counter page as the in the toolbar you can see that Riverpod counter page. Now if I click on this button, then values are increasing, right? So this is a very simple example of Riverpod. Okay, I hope you understand this, and why because as Riverpod is nowadays, it is very popular in implementing in the Flutter application. So I came up with this today's session with this important topic for who is to learn Riverpod, and also who are working in Flutter. So this is important for them. So if you like this video, please share to others, and if you are new to this channel, please subscribe so that you can able to see or watch similar kind of videos in future. Thank you for watching. I will see you in the next.